All right, properties of functions. So if we have an increasing function, that means it's going like a line with a positive slope. It's increasing throughout its domain, right? So it's going up and to the right. If a function is decreasing, that's the part of the function. Maybe I have a function like this, and this thing is decreasing on its domain. If I have a constant function, then it's just flat, right? It's not increasing or decreasing. It's just constant, like a line that has a slope of 0. A relative maximum is or it's also referred to as a local maximum, is the highest point in an area. The relative minimum is the lowest point. We'll go ahead and do some of those here, looking at this graph. So where is this increasing? And so I'm thinking to myself, where from left to right, when is it going up and to the right? And can you see how it's going up and to the right in this area right there? And I name this as intervals, as x intervals, from -3 to an x value of 0, from an x value of -3 to an x value of 0. Now, it's always open intervals. It's not the include or exclude, it's not the brackets. It's always an open interval that you're naming on which a function is increasing or decreasing. So you don't have to worry about brackets and all that stuff. And it's also increasing. Notice it's increasing over here to the right from an x value of 2 to that x value of 4. So from 2 to 4, it's also increasing. So on both of those, it's increasing, both of those intervals. All right, where is this thing decreasing? Down and to the right. Can you see how it's decreasing right there? From an x value of 0 to an x value of 2. From 0 to 2, this function is decreasing. Now, where does this have a relative maximum? Relative max. So the highest point in the area is right there. So that point right there, 0, 3, is the relative max. 0, 3. So what we say is, or the local max is the same thing, is 3. It's the functional value. It's the y value there. What's the highest point? Well, highest or lowest is referring to the y values. What is the relative maximum? We did the relative maximum. That's supposed to say minimum. Sorry about that. Minimum. What is the relative minimum? Well, the lowest, the y value, where's my lowest point? Well, it hits here at both places. So the minimum's at -3, 0, and at 2, 0. Well, what is it? The local or relative minimum. What's the lowest functional value? 0. So it is, if they ask you for a point, give them both points. If they ask you for the actual minimum, local minimum or relative minimum, give them the y value. Yeah, so what is the relative minimum? Relative or local min is 0. All right, let's move on to another one here. Where's this increasing? So I'm looking, where am I going up and to the right? Can you see how from here to here on that red interval, I'm going up and to the right. So from this x value to that x value, from an x value of -2 to an x value of 0. And notice over here, I'm also going up and to the right from an x value of 3 to an x value of 5. Again, these are always open intervals when you're talking about increasing, decreasing. Now, where is this decreasing? Let me erase these real quick. Where am I decreasing? Well, can you see how you're going down and to the right here? So from an x value of -3 to an x value of -2, I'm decreasing. And I'm also from here to here, I'm also decreasing as well, from an x value of 0 to an x value of 3. Let's do the numbers where it has a local minimum. So local minimum is in an area. So let's say I'm just looking in this area. Forget about this for a minute over here. Just in this area, what's my lowest point? I'd say it's right there. That's one of my local minimums. -2, -3. So local min of, there's a local min of -3, and it occurs at x being -2. That's how you say that. Now, where's the other minimum? Where's the other minimum? Let me erase this. Now, let's just look in this area over here, and let's forget about the left-hand side. In this area, that's my lowest point right there. So it also has this point, 3, -5, is a local or relative minimum. Local min, what is the local min of -5, the functional value? It occurs when x is 3. Occurs when x is 3. All right, now we're looking for maximums, local maximums. So I'm looking for a top of a hill. So I'm like, well, let me look at this graph. And it looks like the only top of a hill is right there, -2, right? So this is the point 0, -2 is a local max, right? It's the highest point in the area, right? In other words, just look in this area, right? That's the highest point in the area. So top of a hill. 0, -2 is the local maximum or relative maximum. So it has a local max of -2, the y value, and it occurs at x equals 0. So the local max is -2. What was our local minimums? The local minimums, if you remember from up here, that's these two statements. The local min was of -3 and occurred at -2. And you also had the local min of -5 occurring at 3, x being 3. All right, what's our domain? Let me come back up here. Let's do our domain now. It looks like it goes from a -3. This is filled in. So -3 up until the 5, but the 5 is a parenthesis, so we do not include an x value of 5. From -3 up to 5, bracket -3. So less than 5, greater than or equal to -3. Now, what's the range on this? Well, let's go back up here. Let me erase this. Let's look at our range. Our lowest y value is right here at -5. The highest value is 0. It's not over here, but it is here. All I care about is it is defined right there at 0 on the left-hand side. So it is defined at 0. So now we're going to talk more about symmetry with even and odd functions. So if a function is even, it means it is, this is what it means. It means f of -x, we're going to use function notation with it, equals f of x. In other words, it's symmetric with respect to the y-axis. I like to think of y equals x squared. Here's y equals x squared. You have the point 2, 4, but if you plug in -2, you get the same y value. So again, f of -x equals f of x to be even. Now, odd means you're symmetric with respect to the origin. In other words, f of -x equals -f of x. So it's symmetric with respect to the origin. I always like to think of y equals x cubed. If you plot y equals x cubed, Oops, I didn't do that very well, but you have the 0.28. So if you plug in -2, you get -8. In other words, f of negative x equals negative f of x. That's your test if you're odd. If you remember before, this is just the function notation for saying replace x with negative x and y with negative y and see if it's the same thing, right? But we're going to do it with our function notation. So let's go ahead and test these to see if they're even, odd, or neither. Is it even? So then, is f of negative x equal f of x is the question, right? So here's our function. F of x is x to the 4th plus 7. Let's plug in negative x for x. And let's see, we get negative x to the 4th. Well, that's -1 to the 4th, x to the 4th. So it just ends up being x to the 4th plus 7. Is this the original f of x? Is that the original f of x? You bet it is. That's f of x. So even. This is even. Now, is it odd? Let me erase some of this stuff. Get this out of the way for a minute. Well, if it's odd, f of negative x would have to be negative f of x. Let's just test it and show that it's not odd. Is it odd? Is this true? Well, you start with the function. You plug in negative x. And you see what you get. And did you get negative the original function? No, we did not end up with that. We ended up with the original f of x. So it's not odd. So it's not odd. This one was even, right? Let's go ahead and do these next few. Usually takes a little bit to do some of these. Let me get some room here. Alright, is this one even? I'm doing B. Does f of negative x equal the original function f of x? Question mark. Well, here's the function. Let's plug in negative x. Let's clean it up. Negative x to the 5th is negative x to the 5th times 6, so negative 6x to the 5th minus negative x to the 3rd is negative x to the 3rd. So we get negative 6x to the 5th plus x to the 3rd. So then the question is that the original? Is this what I started with up here? Is f of negative x equal f of x? No, they're different. So this is not even. I did not get the original. So then the question is this odd? Well, if it's odd, we got to get negative f of x, right? So again, we're doing the same thing. We start with the original, 6x to the 5th minus x to the 3rd. I plug in a negative x to see what I get. And if it's odd, I should get negative the original. I should get negative the original. Well, the original was 6x to the 5th minus x to the 3rd. Is that what I got? Did I get opposite the original? Is that here? Yes, it is. So this is odd. This one's odd. I got negative the original function. All right. Let's clean these up and do C. All right, let's do C now. Oops. Again, we're testing, is it even? Do I get this? Or is it odd? When I plug in negative x, do I get negative f of x, or is it neither? So let's test it first. Is it even? Here's f of x. Plug in negative x. And I say, is that the original? Is this and this the same? No. So it's not even. When I do that, is it odd? Erase this for a minute. Is it odd? When I plug in negative x, do I get opposite the original? Well, here's the original, x squared plus x. When I plug in negative x, we got negative, I'm sorry, that's x squared minus x. So did I get negative the original? In other words, did I get negative x squared minus x? Is that what I get? Nope, I did not. So it's not odd. So since it's not even, it's not odd, I just say it's neither. Neither on that. And we move on. All right, let's check this one. Is it even? Does f of negative x give me f of x? Well, here's f of x. F of x is the absolute value of 2x over x. If I plug in negative x, let's see what we get. I get the absolute value of negative 2x over, oops, I forgot to put a negative x in for x. That's a negative x right here. Sorry about that. Now the absolute value of a times b is the absolute value of a times the absolute value of b, if you've forgotten that. So I can take the absolute value of 2 and just call it the absolute value of 2x. So we get the absolute value of 2x all over negative x. Is this the original? I say nope, so not even. Now the question is, so is it odd? Again, we already did the work, but with odd, we're just trying to see if we got negative the original. So did I get negative the original? Negative the original, did I get that down here when I did the work? Well, I did. I ended up with the absolute value of 2x over negative x. Well, that negative can go up top. That's the same thing. So it is odd. So this one's odd. It's not even. This one ended up being odd. We got negative the original. Let's do this last one. All right, let's check this last one. Let's check it. Is this thing even? When I plug in negative x, do I get the original? Well, here's the function. Let's plug in negative x and see what we get. Bring it up here. Negative x cubed is negative x cubed. Negative x squared is x squared minus 9. And then I say, did I get, when I plugged in negative x, did I get the original function? Is this the original that I started with over here? Or the original that I had in the problem? And I say, no. So this is not even, right? Not even. So then the question is it odd? And well, if it's odd, when I plug in negative x, I should get opposite the original. I should get opposite the original. So well, we already did this work. When we plugged in negative x, we ended up with this negative x cubed over x squared minus 9. So the question is, did I get opposite the original? Well, the original is this x cubed over x squared minus 9. Did we get that here? Are these and this the same? Yes, they are. So this is odd.
On top.
All right, let's take a look at average rate of change. Average rate of change it's just an estimate of your slope. So basically how much something changes between x and c. Okay, so the formula, so average rate of change. And let me give you like a curve for a minute. Like let's say you're going from here to here. You're just going to average it out with a slope. value. You know, average it out with a slope value. So from this point to this point, what's the slope? That's what your average rate of change is. Another way, it's kind of like, okay, I jump out of an airplane and I'm dropping so fast after 1 second. And even though after 3 seconds I'm dropping faster, I can find an average rate of change between those 2 points, right? It's an average. It's not an instantaneous. It's just an average rate of change, an average speed over that time second from 1 to 3 while I was dropping. And that's what we're doing with average rate of change. So just think slope. Find your slope. So find the average rate of change of negative 3x squared plus 3 from 0 to 2. Let me give you a picture of this. Oops. So we're going from here down to wherever this is, and we're just finding this slope. So it'll be negative. It'll be a negative slope. So what you want to do is, first of all, use the x values. They're going from 0 to 2 something. Those are your x values. So what's the y values? First of all, you got to find the y values. Well, if f of x is negative 3x squared plus 3, if I plug 0 in, I get 3. There's my y value. Now let's do it for the 2. Negative 3 times 4, negative 12, plus 3, I get negative 9. Okay, now I have my 2 points. Find your average rate of change. Find your slope. Find your slope. Erase this. So, average rate of change, y2 minus y1 over x2 minus x1, or f of x2 with function notation over f of x1 over x2 minus x1, same thing. So your slope is, I need to name this x1, y1, x2, y2. So my y2 is negative 9 minus the y1 of 3, x2 is 2 minus 0. So my average rate of change, or my slope, is negative 12 over 2. In other words, negative 6. So I average a drop of 6, maybe this is in feet, this is in seconds, feet per second. All right, let's do it for this one. Average rate of change from 1 to 3. Next value 1 to 3. Well, let's find f of 1 by plugging it in. So we have 1 minus 1 plus 2 is 2. F of 1 is 2. Put that in for the y value. Now let's find f of 3. So 3 cubed minus 3 plus 2. I'm plugging it into the original f of x there. So 27 minus 3 plus 2, 24 plus 2, or 26. 26. Now let's find the average rate of change. So let me erase this, give myself a little room. Average rate of change is the slope. So y2 minus y1 over x2 minus x1. So 24 over 2, or 12 is my slope, or average rate of change. Now let's do it for this. This one here, last one, we got the square root. So we're going from 9 comma something to 16 comma something. Well, f of x is the square root of x, so f of 9 would be the square root of 9, which is 3. So there's the y value. Now we're going to do it for 16. So square root of 16 is 4. And now we're going to find the average rate of change, y2 minus y1 over x2 minus x1. y2 is 4. minus 3 over x2 is 16 minus x1 of 9. So I got 1/7 is my average rate of change, or my slope for this. Thanks so much for watching. See you next time.